On October 18, 2025, the International Interstellar Object Consortium released the raw data from the most detailed observation ever made of a cosmic visitor. 4 days earlier, the James Webb Space Telescope had pointed its infrared instruments at 3I Atlas, an interstellar object detected in March, crossing our solar system at speeds that defy expectation. The data entered the public domain in less than a week, but the International Astronomical Union's Small Bodies Division kept its preliminary analyses under wraps, citing only extended review. When one agency releases and another withholds, something is happening behind the scenes. What exactly did Webb capture on the night of October 14th? If you follow this channel, you know that interstellar objects are nothing new. Oumuamua in 2017, Borisov in 2019. But 3I Atlas is rewriting the rules of the game, and before we dive into the anomalies keeping astronomers up late, subscribe to the channel and hit the notification bell. What we're about to discuss here won't appear in conventional news anytime soon. It was first detected on March 12, 2025 by the Atlas system in Hawaii, already within Jupiter's orbit, traveling at 87 kilometers per second. That's 194,000 miles per hour. A typical solar system comet coming from the Oort cloud reaches about 30 kilometers per second when it crosses Earth's orbit. 3I Atlas is moving almost 3 times faster. This speed, combined with its hyperbolic trajectory, confirms its extrasolar origin. It wasn't born here. It came from another star system, traversing the interstellar void for tens of thousands, perhaps millions of years. Its deviation from the galactic ecliptic, the plane where most Milky Way stars orbit the galactic center, was less than 0.02 degrees. Think about that. The probability of a rocky fragment ejected by stellar tidal forces maintaining this alignment, traversing light years of interstellar space, is statistically close to zero, less than 0.1%, according to orbital dynamics models. Natural fragments tumble, deflect, and experience gravitational torques from nearby stars throughout their journeys. 3I Atlas seems to have followed an almost perfect firing line. The Very Large Array in New Mexico coordinated radio frequency observations. The European Southern Observatory in Chile mobilized the Almay Array for millimeter wave scans. In South Africa, the Meerkat Radio Telescope recorded low-frequency emissions during specific windows. 3 hemispheres, 4 types of instruments, all converging on the same target. Such international coordination is not common outside of rare events like total solar eclipses or potentially hazardous asteroid flybys, but 3I Atlas warranted this level of attention. International coordination is uncommon outside of rare events like total solar eclipses or the passages of potentially hazardous asteroids, but 3I Atlas warranted this level of attention. Helena Seraph, an astrophysicist at the Austral Radio Astronomy Institute, stated in a restricted technical note, "The coherence of radio signals across multiple listening stations suggests a point source, not diffuse. It's not noise, it's not terrestrial interference, it is the object." Dr. Kento Aizawa from the National Astronomical Observatory of Japan commented in a private interview, "If it were just one anomalous reading, we would discard it. But all our instruments, regardless of methodology, are in agreement. This should make us very, very attentive." The image revealed structure, not a diffuse smudge, not a pixelated blur. Geometric structure, regions of differentiated thermal brightness, sharp contrasts on scales of tens of meters. For a natural object fragmented by tidal forces, we would expect an irregular surface and chaotic thermal distribution. What Webb showed was different. The thermal signature in the mid-infrared presented temperature peaks reaching 285 Kelvin in specific regions of the surface. For context, 285 Kelvin is about 12 degrees Celsius. Doesn't seem like much, right? But sublimation models predict that an object of this size, 3 astronomical units from the Sun, would heat up at most to 190 Kelvin in the most exposed regions. The 95 Kelvin difference cannot be explained by variable albedo or common surface composition. Something inside or on 3I Atlas is generating additional heat. Radiogenic decay is the favored naturalistic explanation, but it requires extreme concentrations of radioactive isotopes, a scenario rare even in primitive meteorites. Asteroids tumble, comets outgas chaotically, creating jets that alter rotation. 3I Atlas should be spinning irregularly, a typical tumbling rotation for ejected fragments. But the light curves, measured over weeks, reveal a 41-hour periodicity, precise to the instrumental margin of error. A 41-hour cycle means that something on this object completes a revolution, or a repetitive process, every 41 hours. There is no oscillation, no detectable precession. It's as if a gear were spinning at a constant speed in a vacuum. This is the frequency of neutral hydrogen, the 21-centimeter line that radio astronomers use to map interstellar gas. But 3I Atlas is not a gas cloud. It is a solid object. During 6-minute windows, repeating every 41 hours, The VLA and Meerkat detected faint but coherent pulses at this frequency. The power is low, about 10 to 115 watts, equivalent to the emission of a small terrestrial commercial transmitter. Comets emit radio when molecules sublimate and ionize under solar radiation. But these emissions are diffuse, chaotic, covering a broad spectrum. The 3i Atlas signal is narrow, centered at 1.42 GHz, with a bandwidth of only 3 kHz. This is not outgassing. This is something far more structured. This is not outgassing. This is something far more structured. Between April and June, as 3i Atlas crossed the asteroid belt, its speed should have been slightly perturbed by close gravitational encounters with Ceres, Vesta, and other large bodies. N-body models predict a cumulative deviation of 0.15 to 0.3 degrees over 2 months. The observed deviation was 0.09 degrees, less than 1/100th of a degree, as if the object were immune to minor gravitational forces, or actively compensating for small perturbations. This sounds absurd in classical Newtonian terms, but the data is there. Spectrometric analysis, performed by Webb's NIR-SPEC instrument, identified absorption lines corresponding to ferrous silicates, iron-rich olivines, and traces of amorphous carbon. So far, nothing exceptional. Chondritic meteorites have a similar composition, but the surface distribution is not homogeneous. Regions with a high concentration of iron coincide exactly with the hottest points detected in the infrared. What's more, the reflectivity in these regions is 40% lower than expected for pure ferrous minerals. It's as if something were absorbing light instead of reflecting it, even at wavelengths where iron should be bright. Borisov, the second confirmed interstellar visitor, displayed a tail 14 kilometers long when at a similar distance. 3i Atlas. Nothing. No coma, no tail, no lateral jets. Long exposure observations in the visible spectrum showed no surface activity. If there is water ice or carbon monoxide in its composition, they are trapped under a crust thick enough to inhibit sublimation, or they simply don't exist. The inferred density, calculated from gravitational models based on minimal perturbations of nearby asteroids, suggests something between 4.2 and 4.8 grams per cubic centimeter. That's dense. Basaltic rocks reach 3 grams per cubic centimeter. Pure iron reaches 7.8. But a mixed object, with porosity typical of fragmented asteroids, rarely exceeds 2.5 grams per cubic centimeter. For 3i Atlas to reach 4.5 J/3, it would need to be almost entirely solid with near zero porosity. This contradicts models of formation by collision or tidal ejection, which always produce porous and fragmented structures. For an object 420 meters in size traveling at 87 km/s, the transit time from the heliopause, the boundary of the solar system, to Jupiter is approximately 18 months. Why did none of the deep sky surveillance systems detect it earlier? Atlas, Pan-STARRS, Catalina Sky. Survey scanned the sky repeatedly. The obvious answer is low albedo. If 3i Atlas reflects less than 4% of sunlight, it would be invisible until it crossed a distance where automated telescopes could capture it against the star field. But objects with such low albedo are extremely rare. Aged comets reach 3 to 6%. Carbonaceous asteroids reach 5%. Below that, we are talking about pure soot, or absorbent synthetic materials. The second explanation is that it simply wasn't there 18 months ago. But this would imply sudden acceleration or a change in trajectory, which violates everything we know about passive orbital dynamics. But that would imply sudden acceleration or a change in trajectory, which violates everything we know about passive orbital dynamics. Comets accelerate when volatiles sublimate on one side, creating a jet that acts like a thruster. This explains orbital anomalies in objects like Oumuamua, but 3i Atlas shows no coma, no tail, or any evidence of active outgassing. The refutation is straightforward. No visible jet, no corresponding change in brightness, no spectral signature of sublimating molecules. This explanation doesn't hold up. Perhaps the radio signals are terrestrial interference, or the thermal signature is poorly calibrated thermal noise. But 3 independent radio telescope networks, on different continents, recorded the same pulses in the same temporal windows. The probability of correlated error between independent systems is less than 1 in 10,000. Webb underwent a complete recalibration in August 2025, and all instruments were validated against reference targets before the 3i Atlas observation. Artifacts do not explain agreement between multiple methodologies. This would explain the thermal excess, but it doesn't explain the emission at 1.42 GHz, nor the 41-hour periodicity without precession, nor the trajectory insensitive to gravitational perturbations. A naturalistic explanation needs to cover all anomalies simultaneously. So far, none can. Fourth attempt. Gravitational lensing or cosmic microwave background. Perhaps what we interpret as emission from the object is actually background radiation amplified by local geometry. but gravitational lensing requires an intermediate mass between the source and the observer. There is no known star, dwarf planet, or dark matter cloud along the line of sight, and cosmic background radiation is isotropic, not point-like and pulsed. Refutation by geometry. There are two interpretative routes that no one wants to say out loud, but which need to be considered. The first, 3I Atlas, is a dense exocomet core with exotic geology that we don't yet understand, minerals that no terrestrial laboratory has studied, decay processes on timescales we haven't modeled. This is the conservative explanation, and it deserves full attention. The second, 3I Atlas, could be an inert technological fragment of ancient extrasolar origin, preserved by the interstellar vacuum. I'm not saying it's an active alien probe. I'm saying that if a civilization launched objects into deep space 100,000 years ago and those objects failed, broke, or were damaged by micrometric collisions, they would still be out there, wandering. And some eventually would cross other star systems. 100,000 years and these objects failed, broke, or were damaged by micrometeoroid collisions, they would still be out there, wandering. And some eventually would cross into other star systems. Astrophysicists like Avi Loeb, who proposed an artificial origin for Oumuamua, argue that we should consider interstellar artifacts as seriously as we look for biosignatures on exoplanets. The question isn't whether technological civilizations exist. It's how many have existed, how long they lasted, and how many of their artifacts still roam the galaxy long after their civilizations have vanished. If we accept the principle of mediocrity, which states that we are not special, then ancient technological objects should be statistically more common than active radio signals. Machines last longer than transmissions. But let's be clear, saying it could be artificial is not the same as saying it is artificial. Occam's razor still applies. Natural explanations must be exhausted first. The problem is, the more data we collect about 3I Atlas, the more natural explanations require increasingly improbable conditions. We are accumulating coincidences. And in science, many coincidences added together eventually demand a new hypothesis. The International Interstellar Object Consortium, founded after the detection of Oumuamua, operates under open data principles. Raw observations must be released within 7 days of collection. They have complied with the protocol. But the IAU's Minor Planet Center, responsible for official classification and dissemination of preliminary analyses, has remained silent since October 18th. The official justification cites the need for extended review due to the unusual nature of the data. Peer review takes weeks, sometimes months. This is normal. But preliminary communications without definitive conclusions are usually issued to guide the scientific community. The delay isn't conspiratorial, it's cautious. And excessive caution, in this case, is fueling rampant speculation. What we do know is that multiple research groups are running parallel models. Universities in Australia, India, Brazil, and Canada have submitted telescope time proposals for follow-up observations. But there's a window closing. 3I Atlas's perihelion, its closest approach to the Sun, will occur on November 11th, 2025. On that date, the object will be 1.18 AU from the Sun, approximately 176 million kilometers. It will be the last opportunity for high-resolution observations before it begins its outbound trajectory. By February 2026, 3I Atlas will be beyond Pluto's orbit, more than 40 AU away. At that distance, even Webb will struggle to resolve details. It will escape the effective reach of our best instruments. Between November 9 and 12, Webb and the Very Large Array will conduct a coordinated 72-hour campaign. Continuous observations, covering multiple wavelengths, synchronized to the second. If the radio pulses continue in the 6-minute windows, if the thermal excess persists, if there's any change in surface activity near perihelion, this campaign will capture it. Whatever 3I Atlas is, we will reveal more in 3 days than in the past 7 months. This is the urgency. After that, it's gone. Forever. There's preliminary discussion, still at the proposal stage, about an interception mission. Uncrewed, obviously. The challenge is speed. To reach 3I Atlas before it leaves the inner solar system, a probe would need to be launched by January 2026, reaching a speed of at least 50 km/s. This is beyond the capabilities of conventional rockets. Multiple stages, gravitational assistance from Jupiter, or nuclear thermal propulsion would be necessary. NASA has studied similar concepts for missions to fast-approaching asteroids. ESA has comet interceptor projects in the simulation phase. But mobilizing resources, approving budgets, and building hardware in 3 months? Impossible within current bureaucratic cycles. A probe would pass by 3I Atlas at high speed, collecting high-resolution images, spectra, and magnetic field measurements in the few minutes of close proximity. This is technically feasible. The estimated cost would be in the range of $800 million to $1.2 billion. For comparison, NASA's Lucy mission, which will visit Jupiter's Trojan asteroids, cost about $980 million. But Lucy had a decade of planning. 3i Atlas gives us weeks. Space agencies sharing real-time data, terrestrial observatories synchronizing windows, laboratories processing spectral samples collected by multiple instruments. The Buenos Aires Declaration of Principles, signed in 2024, establishes that interstellar objects should be treated as global scientific heritage. If 3i Atlas is confirmed as an extremely rare natural phenomenon, this is sufficient to justify maximum cooperation. If it is anything else, the justification becomes even more urgent. In the next 22 days, until perihelion, each new observation will refine our understanding. If the radio pulses intensify near the Sun, if there is a sudden release of volatiles, if the rotation changes, then we have an atypical exocomet and need to revise extrasolar planetary formation models. If nothing changes, if 3i Atlas remains inert, symmetrical, silent except for regular pulses, then we face an object whose nature does not fit any existing category. And then we need to have a serious conversation about what it means to find an ancient artifact in deep space. The philosophical implication is as profound as the scientific one. If technological civilizations are common in the galaxy, and if they tend to launch objects into space before disappearing, then interstellar space is filled with silent ruins. Broken probes, habitat fragments, space debris from empires dead for ages. Perhaps the galaxy is an archaeological graveyard, and we have only just begun to excavate. Or perhaps 3i Atlas is just a strange rock, and our tendency to see patterns in chaos is deceiving us again. Perhaps the galaxy is an archaeological graveyard, and we've only just begun excavating. Or perhaps 3i Atlas is just a strange rock, and our tendency to see patterns in chaos is deceiving us again. We discard hypotheses one by one until only the one resisting all attempts at refutation remains. 3i Atlas is accelerating this process. Either it confirms the universe produces more bizarre geology than we imagined, or it forces us to rewrite how we search for intelligence in the cosmos. We no longer seek only radio signals directed at us. We also seek the wreckage left behind, the cold whispers of civilizations that no longer respond. And as 3i Atlas slides toward the Sun, silently carrying its secrets, the universe seems to pause for a moment and look back at us, waiting to see if we will finally understand the question it has been asking for billions of years.